Welcome back to Environmental Economics for the second lecture in this series. This week on public goods and the tragedy of the commons. Most of today will be dedicated to insights from Neoclassical Economics, where we will revisit why economists seem to like markets so much, and we spend time on different market failures identified by Neoclassical economists. Last week, we had talked about planetary boundaries, carbon budgets, and shares in emissions. Well, I argued that neoclassical economics and its focus on relative scarcity makes it unfit to guide questions of optimal scale that we face in the Anthropocene. I do still think that there is value in studying environmental economics, even if only because many existing policy measures are inspired by these neoclassical insights. Today's lecture will comment on 3 required readings. For this week, I included the recent survey of the global public goods literature by Buchholz and Sandler, a bit more dated review of the tragedy of the commons by Stevens, and we also spent attention to critiques by Ostrom. Since not all of you are students of economics, let us get a bit more acquainted with the main school of economic thought of today, Neoclassical Economics. Neoclassical economics is what is called a meta-theory. That is, it is a set of implicit rules or understandings for constructing satisfactory economic theories. Its fundamental assumptions are not open to discussion in that they define the shared understandings of those who call themselves neoclassical economists, or economists without any adjective. Maybe a tad arrogant, but probably recognizable to students of economics that most of their curriculum is neoclassical. Anyway, let's continue with the quote. Those fundamental assumptions include the following. 1. People have rational preferences among outcomes. 2. Individuals maximize utility and firms maximize profits. 3. People act independently on the basis of full and relevant information. Neoclassical economics has been the main school of economic thought since Jeffen's mid-19th century. The neoclassicals were first named as such by Karl Marx. What distinguished them from their classical predecessors was both their value theory and their introduction of mathematics in economics. While classical economists were concerned with the source of value in the economy, neoclassical economists argued that the value of things is subjective in nature. Beauty is in the eye of the beholder. University College London professor Mariano Mazzucato explained in a TED Talk on economic value, so the revolution here is a change from objective to subjective. But also the logic is no longer one of what is value, how is it being determined, what is the reproductive potential of the economy, which then leads to a theory of price, but rather the reverse, a theory of price and exchange which reveals value. Now that is a huge change. The neoclassical economists may have inherited their fascination with the market mechanism and its apparent ability to steer seemingly self-interested behavior to serve the collective interest from classical economists like Adam Smith. I skip reading this quote because many of the economics majors may be a bit tired of Smith quotes already. That it is not for the benevolence of the butcher and blah blah blah. We can recognize the behavioral assumption of self-interest in the Homo economicus that is nowadays increasingly ridiculed. To illustrate the prevalence of this behavioral assumption, consider the quote by Nobel laureate Paul Krugman. What we know as economics is the study of those phenomena that can be understood as emerging from the interactions among intelligent, self-interested individuals. While it may sound that Krugman reduces economics to game theory, the assumption of self-interest need not be as extreme as it may first sound. The self-interested individuals can still care about other individuals or have distributional concerns, as these can all be included in the utility function of the agents that we model. We will make use of some very simple stylized models to illustrate how neoclassical economists understand efficiency, market failures, and their solutions. Consider a two-person economy, A and B, let's say Anna and Billy. And let's further assume that there are only two products in this economy, X and Y, let's say Choconostle and Yaka. The box depicts the amount of Billy's Choconoscles on the x-axis and her amount of Yaka on the y-axis. The x's for Anna are reversed so that her number of Choconoscles are increasing from the right to left, and her Yaka consumption increases from the top to bottom. This box is also called an Edgeworth box. It is often used to illustrate the concept of Pareto efficiency. And note that the size of the box is equal to the size of the economy. Let us consider first this point A, where we see two lines cross. These lines represent indifference curves and indicate different combinations of Choconostle and Yaka that leave Anna and Billy with the same utility, or happiness if you will. For example, this IB0 is one of Billy's indifference curves. We see that it is slightly convex, illustrating a standard economics assumption of diminishing marginal utility. That is, when Billy has a lot of Yaka, she is willing to give up more Yaka for a few Choconosles, while she will ask more Choconosles when she has fewer Yaka. In other words, the slope of the different curves gives the marginal rate of substitution between Yaka and Choconoscle that leave Anna or Billy their utility unchanged. Now, with this in mind, is point A efficient? No, point A is not efficient because trade could improve the welfare of either Anna or Billy or both, without making the other worse off. That the indifferent curves cross means that their slopes are not equal to each other, and so Anna and Billy are willing to trade Choconoscles and Yakas at different rates from each other. Point B, on the other hand, shows tangency between indifference curves of Anna and Billy, which says that they are only willing to trade in the same rate, which no longer leaves room for Pareto improvements. Thus, this point B is Pareto efficient. It is always good to remind ourselves that Pareto efficiency says little about the desirability of the distribution. As illustrated in the Edgeworth box, Pareto efficient allocations are not unique, and efficiency says nothing about the fairness of the distribution. And Perman and colleagues wrote that the attainment of efficiency is simply the exhaustion of possibilities for mutually beneficial exchange. Next, it is possible to extend this two-person economy with inputs into production of capital and labor, K and L, and similarly find an efficient allocation of production factors. Here, the marginal rates of technical substitution between capital and labor need to be equal for different isoquants of producing a certain number of Choconoscle or Yaka. Subsequently, the following picture depicts a production possibilities curve that runs from Ym to Xm, the maximum number of Yaka and Choconoscle that can be produced. This economy will be efficient where the marginal rate of transformation between Yaka and Choconoscle is equal to the two marginal rates of substitution of Anna and Billy, or a representative consumer whose indifference curve we see here depicted as II. Economists like Kenneth Arrow showed that the market would give such efficient outcomes for a more general case of end products and under which assumptions. I spent a bit of time on this mini general equilibrium model to help you become more familiar with the terms of marginal rates of substitution and marginal rate of transformation. But many of you will be most familiar with the partial equilibrium representation of equilibrium inefficiency. The idea here is that the demand curve represents marginal benefits of consumption of Chokonoskli, and the supply curve represents the marginal production cost. Under assumptions that we will relax soon, we find the efficient outcome where marginal benefits equal marginal cost of production. For a smaller x than x star, the willingness to pay exceeds the cost to produce additional Chokonoskli, so production will rise. Yet, above x star, the production cost for additional Chokonosklis exceeds the willingness to pay. Possibly the most common market failure is due to externalities of production or consumption, where externalities refer to the uncompensated external effects. Here, Arrow points out that the explanation of environmental problems as due to the non-existence of markets is similarly an insight of purely neoclassical origin. So consider another example market. Let's say that the figure represents the partial equilibrium analysis for yucca in Mexico. Yucca, or Artocarpus heterophilus, is native to India and Sri Lanka. So growing yucca in Mexico as an introduced species comes with some external costs. Here labeled as SMC, short for social marginal cost. The demand for yucca is assumed to be constant as Py, and the supply driven by the private marginal cost of production. Without government intervention, the production of yucca will find its equilibrium where marginal production costs equal the willingness to pay in Y0. However, the socially efficient outcome occurs where externalities of production are also accounted for in Y star. Pigou first identified this market failure as a motive for government intervention through taxation. In this example, the government could levy a tax on the production or sales of yucca, and when this tax is set equal to the marginal external costs in the optimum, this tax will help to achieve efficiency through the internalization of the external effects. In other words, it makes the incentives of the private sector more in line with the common good. A second market failure concerns the provision of public goods. The double dichotomy in the following table helps to characterize public goods. Public goods are those whose consumption is both non-rival and non-excludable. For rivalrous goods, the consumption by one diminishes the consumption possibilities for others, whereas excludability refers to the ease with which consumption can be denied. Examples include climate stability or biodiversity for public goods. These characteristics lead to the underprovision of public goods by the market. That is, unlike as with private goods, where we found that efficiency, marginal rates of substitution equal the marginal rates of transformation, for public goods we should add all marginal rates of substitution because of non-rivalness. To determine the efficient level of the public good, the joint appreciation of the public good matters. The efficient level of the public good in this example would be X star. Unfortunately, the non-excludability of consumption gives rise to free riding or easy riding behavior in the contribution to the public good. This free riding behavior could be considered a special case of the externality problems that we just discussed. The benefits of contributions to the public good are partially external, for which reason underinvestment occurs from the public perspective.